Okay, let's start oscillation. We will discuss the concepts immediately, then we will solve the PYQs, previous year questions. Okay.
Okay,
So in
sir.
oscillations, we will study about simple harmonic motion. Simple harmonic motion. In simple harmonic motion, the object moves to and fro about its mean position. So, for example, if consider this is a spring attached to a rigid support, and the other ends of the spring, other ends of the spring is attached to the block. When the spring is unstretched, in unstretched condition in equilibrium, that position of the spring or that position of the block is called as mean position. This is called mean position. Now if I stretch the block and release it, due to the spring it will oscillate to and fro like this. So this position is called positive extreme position, and that position is called as negative extreme position. The distance between mean and extreme position is called as amplitude, right? So amplitude is denoted by capital A. It can be smaller, it can be bigger. Amplitude of the SHM decides the strength of vibration, right? So when the amplitude is smaller, the strength of vibration is smaller. The amplitude is bigger, the strength of vibration is also bigger. So there is a constant related to the spring called spring constant. We will denote it by K, and the mass of the block is denoted by M. When you stretch the spring, spring will apply some force on the block, right? When you stretch the spring by displacing the object either on the right side or on the left side of the mean position, always the spring pushes the object opposite to the direction in which it is displaced. I will tell you, suppose I am displacing the spring or I am displacing the block on the right side. If this is the direction of displacement, the force applied by the spring will be on the left side, because it will try to unstretch it. Correct? When I displace the spring on the left side, when the displacement is occurred on the left side, now the spring will apply on the force in the right direction. Correct? So can you see that force is always opposite to the displacement? We can write mathematically that the force first condition is the force is opposite to displacement. This is the first condition. Second condition is when you stretch with a smaller amount, the force will be smaller. When you displace it with a higher amount, the force will be higher. That means force is directly proportional to the displacement, amount of displacement. So therefore, combining these two mathematically, we can write for F is directly proportional to minus of X. Negative indicates that opposite direction, and X is the displacement. Since force is directly proportional to displacement, I can write F is directly proportional to X, and negative indicates the opposite direction. Therefore, I can write the complete equation by introducing a constant F is equal to minus K. This is the very first equation you must remember. This is the equation of restoring force. Restoring force or force due to spring. Okay, understanding it? Are you following me?
Yes, sir.
So, have you studied simple harmonic motion previously?
Yes, sir.
Okay, so I'll go fast, right? So, if, restoring force is given by this equation, and the spring constant can also be written by m omega square. Please remember this equation because many of the students don't remember this equation. This equation is introduced in our syllabus without any proof. So, I will write k is equal to m omega square, where k is the spring constant, k is the spring constant, which is also known as restoring constant. M is mass of the block, and omega is angular velocity. Angular velocity. Correct? So this is the second equation you must remember. We can even substitute in the above equation to get the force in terms of mass and omega. So let us do that F is equal to minus m omega square into x. So according to Newton's second law, we can write F as ma. Therefore, minus ma is equal to m omega square minus omega square into x. I can cut m and m to get the acceleration of SHM as minus omega square x. This is called acceleration of SHM. So whenever a body is performing SHM or whenever a body is vibrating about its mean position, its acceleration is given by this equation, minus omega square x. Now you can see at the mean position the value of x will be 0. We can write the acceleration at different points, right? So at mean position, what will be the acceleration? At mean position, I can put x is equal to 0, correct? So when I put x is equal to 0, the acceleration becomes 0. Similarly, at both the extremities, I can put x is equal to plus minus a, because at positive extreme position I can substitute x is equal to plus a, and at negative extreme position I can put x is equal to minus a. So if you put x is equal to plus minus a, you will get acceleration as a is equal to minus plus omega square a. So you can see at mean position there is no acceleration, at the extreme position there will be highest acceleration. The magnitude of acceleration will be highest at the extreme position, highest acceleration, and this will be the lowest acceleration. So where the acceleration is maximum? At the extreme positions. Now similarly we can solve the above equation as a differential equation to get the formula for speed of the or velocity of SHM. Velocity of SHM. Can you remember what is the velocity of SHM? V is equal to plus minus omega under root a square minus x square. Do you remember this equation?
Yes, sir.
Okay. Now even we can substitute x, the value of x as 0 here. At mean position, what will be the velocity? At the mean position, if I put x is equal to 0, I will get velocity as plus minus a omega. Check karo. Because when x is equal to 0, a square under root of a square will be equal to a. So it will be a omega. And if I want to find the speed of the SHM at extreme position, the value of x will be equal to plus minus a. Therefore, velocity will be equal to 0. It is clear that when the particle vibrates about its mean position at both the extremities, the particle will be momentarily stopped. If you don't understand, I will show you one animation. See, can you see this? The particle is momentarily stopped about its mean position. Sorry, when it is at extremities, right?
Yes, sir.
Everything is plotted here. Graph of displacement, velocity, acceleration, in potential energy, kinetic energy. Everything is visible.
Acceleration is slow.
Yes, acceleration is very low. We can increase the spring constant to get more acceleration. Everything is here. This website is check this website. You will be amazed. This website is amazing. The name of the website is O Physics. You can check all the animations are given here. All the physics animations are given here. You can play with the animation, even visibly you can see the concepts of physics. Very nice website.
Okay, sir.
Okay, moving to the next concept. So we have seen that acceleration is given by minus omega square x and velocity is given by this entire equation. Now we can see that the displacement of SHM, displacement about its mean position is x, and the value of x can be written as a sine omega t plus phi. A sine omega t plus phi. This is the equation of displacement of the particle about its mean position. Displacement about the mean position. Now, here A for amplitude, omega for angular velocity, t is the instantaneous time. What is phi? Phi is known as epoch. Epoch means initial phase. Initial phase. Now, there are many cases. You can remember that phi is taken to be 0 degree. Correct? Because phi is an angle. So it is called initial phase. Phi is 0 in the case when the particle starts from mean position. When the particle starts vibrating from mean position. If the particle starts its motion from its mean position, I will take phi is equal to 0. Similarly, phi can be taken as 90 degree if the particle starts from positive extreme position. When in that means if initially the particle is at extreme position, positive extreme position, I will take the value of phi is 90, and if the particle starts from mean position, I will take the phi value as 0 degree. Okay, understood? Now, energies of SHM, kinetic energy of SHM can be written as half mv square. Now we know what is the formula for velocity. The formula for velocity is omega under root a square minus x square, the whole square, because velocity square is there. Therefore, kinetic energy will be simplified to be m omega square bracket a square minus x square. This is the formula for kinetic energy. I can put m omega square as k also. See, the second formula I told you, I can put m omega square as k. Therefore, the formula for kinetic energy will become in terms of k as half into k bracket a square minus x square. This is the formula for kinetic energy. Understood? Similarly, formula for potential energy can be written as half kx square. And the formula for total energy will be equal to potential plus kinetic energy. So when you do it, half kx square gets cancelled, and the remaining formula for total energy will be equal to half ka square. You have to remember these three formula. Amar Akbar Anthony. Kinetic energy, potential energy, and total energy. Also, we will have simple pendulum here. Do you know what is simple pendulum?
Yes, sir.
Simple pendulum is a heavy bob attached to a spring, and the other end of the spring is fixed to a rigid support. So when the
Sir,
bob is
what is
displaced, when the
related
heavy sphere
to
is displaced about its mean position, it will perform to and fro motion, which is exactly SHM. So the time period of SHM is given by this equation. T is equal to 2 pi under root L by G. Time period of SHM. Time period of simple pendulum. Okay. What is L? L is the length of the string, and G is the acceleration due to gravity. So based on these equations, we can solve all the questions of simple harmonic motion. If there is some new equation, I will introduce you while solving the questions. Okay. Oscillation is 114. Let's go to page number 114. Okay, this is oscillation. See, this question was asked in NEET 2021. Please read the question. A body is executing simple harmonic motion with frequency n. The frequency of its potential energy is. Now, see, a body is performing simple harmonic motion with frequency n. The frequency of its potential energy is. Now, what is the formula for potential energy? potential energy in SHM is equal to half kx square. Now remember, potential energy can be written as half into k. What is x? Can I say x is equal to a sine omega t? Let us take the value of phi as 0. Okay. So a square sine omega t, correct? The potential energy becomes half into k into a square into sine square omega t. Now, do you remember this formula in uh, what do you say? In trigonometry, there is a formula sine square theta is equal to 1 minus cos 2 theta upon 2. Do you remember this formula?
Yes, sir.
Okay, so we can put here to get potential energy as half into k into a square bracket 1 minus sine square omega t can be written as 1 minus cos 2 omega t upon 2. Now let us simplify the equation to get potential energy as 1 by 4, 2 to the 4, k a square bracket 1 minus cos 2 omega t. Can you see in the formula in the formula of potential energy I am getting 2 omega. What does this 2 omega means? In the formula for x, I will write the formula for x. You can see the in the formula for x it is omega. Omega decides the frequency. So in the expression of x, it is angular velocity is omega, and in the expression for potential energy, it is 2 omega. That means the frequency would be 2n. Have you understood this?
Yes, sir.
Now let us say identify the function which represents periodic motion. What do you mean by periodic motion? See, whatever you will do to check whether it is periodic motion or not, you will write this equation. Do you have mathematics
No,
subject
sir.
as mathematics? No. Okay.
No.
So the function is said to be periodic if it repeats itself after time t. The function is said to be periodic if it gives you same value after time t. For example, sine function. Pay attention. Sine function. This is the graph for sine function. This is one cycle of sine function, right? After one time period, the sine function repeats itself. Then again it repeats itself. Can you see? So sine function is said to be periodic because it gives you same values after every one period of time. That's why it is called periodic. So therefore, the definition of periodic means it gives you same value after equal interval of time. So how can we write mathematically? Suppose there is a function f of t. Any function can be given. If f of t is periodic, if f of t is periodic, then f of t plus t would be equal to f of t. Understand this condition. Very important condition to decide whether the function is periodic or not. See, remember, if this condition is satisfied, f of t plus t is equal to f of t, then the function is said to be periodic. How? See, here only time t is given, and here time t plus capital T. That means this duration is the time t, and this duration is t plus t. Can you see both the function gives you same values? If both the function gives you same values, then the period it is periodic. That's why we are equating f of t plus t is equal to f of t. Did you get the equation? Did you get the condition? So in the equation number 1, what is f of t? F of t for the first option is e power omega t. So what will be f of t plus t? At the place of t, you put t plus t. So f of t will be equal to omega t plus t. Now are they equal? So they are not equal. Therefore, this function is non-periodic. Cancel out it. Clearly, it is also not equal. Clearly, it is not also not equal. Now, I will try option number C. Let us say f of t is equal to sine omega t plus cos omega t. What will be f of t plus t? At the place of t, you put t plus t. Therefore, sine omega t plus t plus cos omega t plus t. Are you getting this? So I can simplify this sine omega t plus omega capital T plus cos omega t plus omega capital T. Now I know what is omega. Can you tell me what is omega? Is it 2 pi by capital T? So let us put this omega as 2 pi by T. So therefore T gets cancelled. Similarly, we can do for cos term also. 2 pi by capital T into T. So this T gets cancelled. And our answer would be equal to sine 2 pi plus omega T plus cos of 2 pi plus omega T. According to trigonometry, what is sine 2 pi plus theta? Sine theta. Do you remember this trigonometric identity that sine 2 pi plus theta is equal to sine theta? So therefore, this can be written as sine omega t, and this can be written as cos omega t. Can you see? This is we have calculated f of t plus capital T. Now f of t plus capital T exactly matches with f of t. You can see. Check. So therefore, f of t plus capital T exactly matches with f of t. Therefore, option number C is periodic. There is a shortcut also. Whatever term contains sine and cos in addition or subtraction. Remember my words. Whatever if the function contains sine function and cos function in addition or subtraction, the function is always periodic. The function is always periodic. So only one option is giving you sine and cos. So without solving, you can mark the option. No need to solve this much long. But still, we have solved that traditionally because you must know the concept. Whatever function contains sine function and cos function in addition or subtraction, the function is always periodic. Okay, beta. Have you understood this? Moving to the next question. Moving to the next question, the phase difference between displacement and acceleration of the particle in a simple harmonic motion is. Now we have to calculate phase difference between acceleration and displacement. So what is the equation of displacement? We remember the equation of displacement is x is equal to a sine omega t. Correct? If I differentiate it to calculate dx by dt, I will get velocity. So let's differentiate it. D by dt of a sine omega t. What is d by dt of a sine omega t? A omega, differentiation of sine omega t is cos omega t. Okay, now again we will differentiate to get the acceleration. What will be my acceleration? Acceleration will be equal to dv by dt. Let us differentiate velocity again. dv by dt of a omega into cos omega t. So therefore acceleration would be equal to a omega. Differentiation of cos omega t would be minus sine omega t. And according to chain rule, omega will come out to get omega a omega square. So you remember this is the equation of x and this is the equation of acceleration. Just watch. Just see that acceleration can also be written as A omega square sine omega t plus pi. Reason for this is we know a trigonometric identity that sine pi plus theta is equal to minus sine theta. Sine pi plus theta is equal to minus sine theta. So instead of this minus sine theta, I have written sine of omega t plus pi. Now you can compare these two equations. You can compare these two equations to say that the phase difference between the displacement and acceleration is pi. The phase difference, because phase is the angle of sine, na? Here it is omega t. Here it is omega t plus pi. So what would be the difference between them? It would be pi. Therefore, option number D is correct. Okay, Rohina?
Yes, sir. Yes, sir.
Now coming to the fourth question, the distance covered by a particle undergoing SHM in one time period is the distance covered by the particle. Okay, so this is the path of SHM. You can see this is the mean position. This is the positive extreme position. This is the negative extreme position. Now the distance between mean and extreme position would be equal to A. So if this is A, this will also be A. Now if the particle starts from mean position, when it will complete one oscillation, it will move towards the positive extreme position, then it will return back, then it will go to the negative extreme position, and then it will return back. Now one oscillation is completed, right? So for one oscillation, the particle is moving something like this. So what is the distance covered by the particle now? Here you can see the particle return back to its original position. Therefore, the displacement, if displacement would be asked, then the answer would be 0. But here it is not asked displacement; they have asked distance. So what will be the distance? Distance is the path length covered by the body. So first is it covers capital A, then again A, then again A, then again A. 4 times A. Have you understood? Distance A is covered 4 times for one oscillation. Therefore, one oscillation distance covered is 4A, displacement is 0. So I will mark 4A because they have asked distance. If they would have asked displacement, I will mark 0. Okay.
Okay, sir.
Next, average velocity of the particle executing SHM in one complete vibration is. Now, average velocity. What is the formula for average velocity?
Option B.
Yes, very good option. No, 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 not option B. Option number C.
0.
What is the formula for average velocity? Total displacement upon total time, na?
Yes.
So what is the displacement in one oscillation? I told you the displacement in one oscillation is 0.
Yes. Yes, sir.
Therefore, substituting 0 at the place of displacement, you will get answer 0.
Okay, sir.
If they would have asked average speed, अगर अगर वो लोग एवरेज स्पीड पूछे होते तो क्या करते थे हम लोग? We will write total distance upon total time. So what is the total distance covered in one oscillation? It is 4A. What is the time for oscillation? It is capital T. So average speed is 4A by T. Moving to the next question. The displacement of the particle executing SHM simple harmonic motion is given by. How to solve this? Do you know composition of SHM? Do you know composition of SHM? No? Suppose first SHM is given by this equation A1 sine omega t plus phi 1. Right? And the second equation is given by this equation A2 sine omega t plus phi 2. So when there are two SHMs, two SHMs of different amplitude and different initial phases, their combination is called composition of SHM. So we can prove that resultant SHM would be equal to V1 Y1 plus Y2, and through long derivation we can prove that resultant amplitude will be equal to under root that vector addition formula, under root A1 square plus A2 square plus 2A1 A2 cos phi1 minus phi2. Do you remember this formula? So please write this formula. This formula is valid only when two SHMs of the same period is combined. Now you can look at the equation. What is given here? Here given is A naught plus A sin omega t plus B cos omega t. Now we have to modify the equation because our function is must always be in terms of sine. So y we can write y is equal to A naught plus A sin omega t and B cos omega t. To now cos won't work here. We have to convert cos into sine. So I must write sin omega t plus pi by 2. Because through trigonometry we know sin theta plus pi by 2 is what? Cos theta. So therefore you can see this is our first SHM and this is our second SHM. Now substituting everything into the equation of resultant SHM, I will get resultant SHM is equal to under root A1 square. What is A1 square? A square. What is A2 square? B square plus 2A1 A2 into A into B cos. What is phi1? Can you see in the equation of y1, phi1 is 0? So 0. Minus what is phi2? Can you see in the second equation it is minus pi by 2? So minus pi by 2. So you can see cos pi by 2 will become 0 na. So therefore this entire term will vanish. So what will be my resultant amplitude? Resultant amplitude would be equal to under root A square plus B square. So under root A square plus B square would be option number A. Now you will say why to leave this, because this is not SHM. This is just a constant. Therefore, I won't take it into consideration. Only SHM part of the equation can be taken into consideration. If it is not SHM, just leave it, because we are calculating amplitude of oscillation. So only those things will be considered which are oscillation. So since this term A naught is not an oscillation, we will just leave it. So rest of the two terms becomes two oscillations, two SHMs combined. Have you understood this?
Yes, sir.
Please write the theory part as well as the solution part. This is important because every time you have to convert cos term into sine term. Whatever cos term or anything is given, you have to convert it into positive sine function. Then and then only compare it and solve it. I'm giving you 1 minute to copy this. Okay, moving to the next question. The question is, the radius of circle, the period of revolution, initial position, and the sense of revolution are indicated in the figure below. The y projection of the radius vector of rotating particle P is. Now we have to take the particle P as a function of y on the y-axis, right? Projection on the y-axis, where P is particle is initially at this point, and we have to take the projection on the y-axis. That means this is the path of SHM. This becomes the path of SHM. This will be the mean position. This will be the positive extreme position, and this will be the negative extreme position. When the particle actually performs circular motion, its projection will be performing SHM, simple harmonic motion. Can you see the amplitude of SHM? Here the amplitude of SHM is equal to 3 centimeter, or sorry, 3 meter. Why? Because amplitude is nothing but the radius of the circle. What is amplitude? Actually, what is amplitude? Amplitude is the distance between mean and extreme position, and it is given as 3 meter. That's why we will take amplitude as 3 meter. So which option gives you amplitude equal to 3 meter? This will be eliminated because amplitude must be 3 meter. Now here the particle starts from positive extreme position, right? The particle starts from positive extreme position because here it is written as t is equal to 0. T is equal to 0 means initially the particle is at the point positive extreme position. When the time starts, the location of the particle was at positive extreme position. Therefore, I told you to take the value of phi is equal to 90 when the particle starts from positive extreme position. Remember? See, when the particle starts from positive extreme position, you have to take the value of phi as 90 degree. So let us write that standard equation first. Let us write the standard equation first. What is the standard equation? A sine omega t plus phi. Hello? जी हम सर. हाँ हाँ. You hear me? So the value of x becomes 3 sine omega t. Now what is omega t plus 90 degree? Sine 90 plus theta is what? Sine 90 plus theta is cos theta. So therefore 3 cos omega t is the answer. 3 cos omega t. Now what is omega t? Omega we have to substitute, na? Omega we have to substitute because omega is a mystery. Now see, at t is given as 4 second. Capital T is given as 4 second in the question itself. So we can use the equation of omega as 2 pi by capital T, right? So substituting capital T as 4 to get 2 pi upon 4 into T. Now 2 gets cancelled and the answer would be 3 cos pi t by 2. Pi t by 2. Understood? Am I audible?
Yes, sir.
So the option number C is correct, no? Yes, option number C is correct. Moving to the next question. Read the question. This question was asked in Neet 2017. Question number 8. A particle executes linear SHM with an amplitude of 3 centimeter. Now the amplitude of SHM is given as 3 centimeter. When the particle is at 2 centimeter from the mean position. Now what is the displacement of the particle from mean position? It is x. So the given value of x is 2 centimeter. The magnitude of its velocity is equal to the magnitude of acceleration, then its time period in second is. In the question they have given when this is so, the magnitude of acceleration becomes equal to the magnitude of velocity. Remember we have the equation of acceleration. What is the formula for acceleration? Is it minus omega square x? So I will just use magnitude, therefore this negative can be cancelled because I'm just using the magnitude of acceleration. And the velocity is given as plus minus omega under root a square minus x square, correct? So let us substitute a is this and v as this in the equation itself. So what it will become? Omega square x is equal to omega under root a square minus x square. So this omega and omega gets cancelled. Omega x will be equal to under root a square minus x square. Now you can put everything into the equation. Let us put x as 2 and amplitude as 3. So 3 square minus 2 square. Omega into 2, 2 omega is equal to 9 minus 4 is under root 5. So what is under root time? Omega can be written as 2 pi by capital T is equal to under root 5. Now taking T alone, you will get 4 pi by under root 5. Now which option gives you 4 pi by under root 5? Option number C is correct. Understood?
Yes, sir.
Okay. Copy this question. Okay, moving to the next question. When two displacement, again see, again superposition, composition of SHM is asked. You see, uh, two displacements are given. I will write it. Y1 is given as a sine omega t, and y2 is given as b cos omega t. Correct? So can we write cos into sine? Yes, we can write. So therefore, we must write b sine omega t plus pi by 2, because through trigonometry we know that sine 90 plus theta is what? Cos theta. So this is our first equation, first SHM, and this is our second SHM in standard form. According to the theory of composition of two SHM, what will be the resultant SHM? Resultant amplitude of SHM will be equal to under root a1 square plus a2 square plus 2 a1 a2 cos phi 1 minus phi 2. Cos phi 1 minus phi 2 like this. So therefore resultant amplitude AR is equal to under root. What is A1? A1 is small a, A2 is small b, plus 2 into a into b into cos pi by 2 minus 0 degree. Correct? What is cos pi by 2? 90 degree. Cos 90 is 0. Therefore this entire term will be cancelled because of 0. Hence a resultant amplitude will be equal to under root a square plus b square. Similar question was asked previously also. You can check. So simple harmonic motion of amplitude a square plus b square is the answer. Next question. Question number 10. Are you getting this? Question number 10.
Yes, sir.
A particle is executing simple harmonic motion along a straight line. Its velocities at x distances x1 and x2 from the mean position are v1 and v2 respectively. Its time period is. Now see, in the equation, in the question itself, we have given that velocity is v1 when displacement is x1 and velocity is v2 when displacement is x2. Let us use the formula for velocity. What is the formula for velocity? Is it omega under root a square minus x square? Correct? So when I substitute x is equal to x1, I must write v is equal to v1. Now putting v2, I must write everything same but x2 square. Correct? So squaring both side, because we have to find omega, we have to find time period, right? So let us substitute, let us squaring both side. V1 square is equal to omega square bracket a square minus x1 square. V2 square will be equal to omega square bracket a square minus x2 square. And we have to make the omega alone, na? So let us take omega square inside the bracket. 1 omega square a square minus omega square x1 square. V2 square will be equal to omega square a square minus omega square x2 square. Now taking this on the left side, v1 square plus omega square x1 square is equal to omega square a square. V2 square is plus omega square x2 square is equal to omega square a square. Can you see these two right hand sides are equal now? Equating them, we will have v1 square plus omega square x1 square is equal to v2 square plus omega square x2 square. Something like this. Any doubt?
No, sir.
Now let us make the omega square alone. Let us make the omega square alone, taking v1 square minus v2 square is equal to omega square x1 x2 square minus x1 square. Omega square x1 square. Let us take omega square common. V1 square minus v2 square. Omega square x2 square minus x1 square. Therefore omega would be equal to under root v1 square minus v2 square upon x2 square minus x1 square. Now we have to find the time period, no? So to find time period, let us put omega as 2 pi by capital T. That is equal to under root v1 square minus v2 square upon x2 square minus x1 square. Now taking t on the right hand side and everything on the left hand side to 2 pi under root x2 square minus x1 square upon v1 square minus v2 square. Which option gives you this answer? I think option number B correct. So have you understood how to solve this? Very simple. Just it takes a lot of algebra, but it can be solved. You can eliminate the steps also if you know algebra. Let us jump to the next question. Can you please read the next question? A particle is executing simple harmonic motion. Its maximum acceleration is alpha and maximum velocity is beta. Then its time period of vibration will be. Very nice question. See, I told you that maximum acceleration. Where is the maximum acceleration? At extreme position. Can you check? And what is the maximum acceleration? A omega square. What is the maximum velocity? A omega. So from the previous knowledge, from the formula of velocity and acceleration, we have that maximum acceleration is equal to a omega square and maximum velocity is equal to a omega. And according to the question, maximum acceleration is given as alpha and maximum velocity is given as beta. So let us divide these two equations to get a cancelled out and omega also cancelled out. Therefore, omega will be equal to alpha upon beta. And we need to find the time period. So let us put 2 pi by capital T as omega, that is equal to alpha upon beta. Therefore, time period would be equal to 2 pi beta by alpha. This is my answer. 2 pi beta by alpha, option number D is correct. Okay. Question number 12 now. Am I going too fast?
No, sir.
The oscillation of a body on a smooth horizontal surface is represented by xc. The equation for x is given a cos omega t. Now x is displacement, omega is frequency of oscillation. Okay. What are they asked? Which one of the following graph shows the correct vibration variation with a with t? Now we need to find the acceleration. No. How to determine acceleration? First we will differentiate x to get velocity. So let us differentiate x. How to differentiate x? D by dt of a into cos omega t. Therefore, v is equal to a cos. The differentiation of cos is minus sine. So minus a omega into sine omega t. Now again differentiating velocity to get acceleration. Acceleration is equal to dv by dt. Therefore, d by dt of minus a omega into sine omega t. So therefore, acceleration will is equal to minus a omega square. Differentiation of sine is cos omega t. Now please check the variation of acceleration is according to the negative cos function. Negative cos function, right? So do you remember this is the cos function? This is the variation of cos function from the maximum value. This is how the graph of cos function varies. Cos x. What about negative cos function? How the negative cos function will be? The negative cos function will be inverse of it. Exactly opposite. This will be the minus cos function. Now, according to the equation, the acceleration varies according to minus cos function and the graph of minus cos function looks like this. So therefore, which option is correct? Tell me which option is correct. This graph matches with which option?
Option C.
Yes, very good. Option number C correct. 13 second. 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 If it would be minus sine function, then you must remember sine function. The graph of sine function looks like this. See, this is how sine function looks like. This is sine function. What about minus sine function? Just reverse it, flip it, flip it like this. This is the graph of minus sine function. Okay. Next question. Which of the following function represent the motion of the particle which represent SHM? SHM, SHM which function? I told you sine function and cos function in addition is always SHM. SHM, right? This is not an SHM because we have sine cube here. Sine cube is not an SHM. Okay. See, this is cos function. Only cos function is SHM always. And this clearly is not SHM because this does not contain any sine and cos function. So we can mark the option number B. 1 and 3 is 1 and 3 are the sinusoidal function. Okay, moving to the next question. Question number 14. The displacement of the particle along x-axis is given by this equation. The motion of the particle corresponds to. Okay, see here the given equation contain x square term a sine square omega t. Now we remember the standard formula does not contain sine square function. The standard formula contains only sine function. So let us convert this into sine or oblique cos function. How to convert? We remember a trigonometric identity sine square theta is equal to 1 minus cos 2 theta upon 2. Please remember this formula. 1 minus cos 2 theta upon 2. So let us substitute this here to get the value of x as x is equal to a 1 minus cos 2 omega t upon 2. Now taking 2 and a inside the bracket, we will have a by 2 minus a by 2 cos of 2 omega t. Now this is just a constant. This term is just a constant. It is not SHM. But this term is an SHM because it contains cos function. In fact, cos can be converted into sine. But no need to convert it because we just have to ask the frequency. Now can you see here omega is 2 omega. The angular velocity of SHM is 2 omega. Here angular velocity is what? 2 omega. What is angular velocity? Can we write 2 pi f? Because we want frequency. Therefore 2 gets cancelled. Therefore frequency would be equal to omega upon pi. Which option gives you omega upon pi? Option number A. No. Option number A is correct. This is wrong. Option number A is correct. It is SHM because it contains cos function SHM. They have solved it wrong. You can scan this question on internet. You will get the right answer. This is my answer is right.
Okay, sir.
Okay. Moving to the question number 15. Because clearly see now, clearly we can modify this equation like this. This is not an SHM, but this equation, part of the equation contains SHM because this is a cos function. Cos can be written in terms of sine, though so it will become standard equation. Question number 15. Which one of the following equations of motion represents simple harmonic motion? Now tell me which equation represents simple harmonic motion. All the options contain acceleration. What is the acceleration in SHM? Acceleration in SHM can be written like this. A is equal to minus omega square x. minus omega square x. So can you tell me which option contains acceleration in this format? Which option contains acceleration in this format? Tell me. Is it option number B?
Option D is also containing same kind of.
Okay, I'll tell you. See, option B is what? A is equal to minus k bracket x plus a, right? So can we write minus kx minus ka? Now this is just a constant, no? It can be neglected.
Yes.
So this part of the acceleration is variable, and variable part decides the SHM. Therefore, this matches with this. Others does not match. If you
Okay.
say option number A is also matching, but A contains x square term, there is no
Yeah.
x square term in SHM. Therefore, option number A is wrong. Option number C is positive, wrong. Option D is also positive, wrong. So only option number B matches with the standard form. Therefore, option B represents the simple harmonic motion. Any doubt?
No,
Remember,
sir.
any constant term can be neglected when we study SHM, simple harmonic motion, because everything in SHM varies. Acceleration, velocity, displacement, everything varies. You want to say anything?
No, sir.
Okay. Question number 16. Read question number 16. Two simple harmonic motions of the angular velocity 100 radian per second and 1000 radian per second have the same displacement and amplitude. Displacement amplitude. The ratio of their maximum acceleration. Now tell me. We know that omega 1 is given as 100, omega 2 is given as 1000. Unit, you can write unit also. The ratio of their maximum acceleration. Now, what is maximum acceleration? Remember, I told you about maximum acceleration as well as maximum speed. What is maximum acceleration? See, I rounded it off. Maximum acceleration is at extreme position and it is equal to a omega square. And maximum velocity is a omega. Many of the questions have asked on this concept. So, maximum acceleration is equal to a omega square. Plus or minus is just for the direction. We need to find the magnitude, so I'm neglecting plus or minus. Okay. So what about a1? A1 would be equal to a1 into omega 1 square, and a2 would be equal to a2 into omega 2 square. Taking ratio on both sides. In the question itself, they have same amplitude. So since they have same amplitude, a1 a2 gets cancelled. And substituting omega 1 and omega 2 in the equation itself to get a1 upon a2 as 100 into 100 upon 1000 into 1000. So this 2020 gets cancelled, 2020 gets cancelled. The answer would be 1 is to 100. 1 is to 100 is option number 2. Any doubt?
No, sir.
Are the questions simple?
No. Moderate.
Okay, moderate. You have to think a little bit because SHM is not easy. It makes you think a lot. Questions are not that directly straightforward, formula based. But if you practice it, you will get it because there are very limited thing in which they can twist you. If you master that, you will learn all the chapters. Okay, 17th question. A point performs simple harmonic oscillation of period t, and the equation of motion is given by this. X is equal to a sine omega t plus pi by 6. They have asked that after elapse of what fraction of time period the velocity of the point will be equal to half of its maximum velocity. After that, what elapse of time the velocity becomes half of its maximum velocity. Now, I will tell you one thing. Pay attention. See, this is extreme position, this is mean position, and this is negative extreme position. Remember, if our particle is performing SHM and completing one complete oscillation, then for this process it would take one time period. Correct? Now, if it is taking half the oscillation, it would take T by 2 time. And if it is performing 1/4 of oscillation, tell me what time it would take? It would take T by 4 time. And if it is going from this position to middle point of the mean and extreme position, this is the middle point of mean and extreme position. See, it would not take T by 8 second, it would take T by 6 second. Please check. How is it so? Because here the velocity is maximum and here the velocity is 0. So in this region, in this first half of the displacement, the particle would be fast, and here it would be slow. Therefore, it would not take equal amount of time to travel it. Hence, it will take less than T by 8 seconds. So therefore, I've written T by okay sorry, I've wrongly written it will take T by 12 seconds, and T by 6 would be this time from here to here, from the midpoint of mean and extreme position to the extreme position. It would take T by 6 seconds. I can easily prove through equations also. If you say so, I can prove all the times. So here the time elapsed, what is asked? The time elapsed that is equal to half of its maximum value. See, after what time, what fraction of time period, the velocity of the point will be equal to half of its maximum value. So what is the answer? Here it is maximum value. Here it will have half the maximum value. Therefore, the answer would be T by 12. Check. Understood?
Yes, sir.
Okay, see the 18th question now. If you say so, I can prove all this time. Shall I prove it?
Yeah, sir.
Okay. So I don't think from one oscillation it would take T. This is already we have understood this. Half the oscillation it would take T by 2, half the total time, and 1/4. Till here you have understood, right? You don't get to how it is T by 12, right? So I will explain T by 12 first. So for T by 12, the particle starts from mean position and goes to the middle point of extreme and mean position. So see, the particle goes from this point to this point. Initially, the particle is from mean position, therefore initial phase is 0. Because what I told you, when the particle starts from mean position, the initial phase would be 0. And the particle is reaching up to the middle point of mean and extreme position. Therefore, the final displacement of the particle will be equal to A by 2. Because at extreme position, it is A. The middle point of A and A will be A by 2. So substituting x is equal to A sine omega 2 plus omega t plus phi. We need to find time duration for this. So let us put x is equal to A by 2 here. Therefore, A by 2 is equal to A sine omega t plus 0 degree. Correct? So this A gets cancelled. And the answer would be, hello?
Yes, sir.
हाँ, मुझे फोन ही नहीं आया। कोई कोई आया ही नहीं, मुझे पता ही नहीं। हाँ, ऑलमोस्ट कंप्लीट हो गया। हाँ, ठीक है। Now, tell me what is sine inverse of half? What is sine inverse of half? Is it 30 degree? But I won't write 30 degree. I will write pi by 6 because we need to put the angles in radian. Omega is what? Omega is 2 pi by capital T into T as it is. So you can see pi and pi gets cancelled and the time would be equal to T by 12. Check. Is it coming T by 12?
Yes, sir.
Now, since we got the T by 12, now the remaining time would be what? From here to here. Please check from here to here it is T by 4. It is T by 4, right? And from here to here it is T by 12. From here to here it is T by 12. So what will be the remaining time? It will be T by 4 minus T by 12. Okay? This will be the time taken by the particle from here to here. From the midpoint to the extreme position. So when you solve this, you will get T by 6. Take LCM and solve this to get T by 6 as answer. So I think I have proven everything. Now I got another lecture. I have to go there.